May have noticed a generalization that we can make when we do rotations of 90 degrees. Now, these only work for rotations of 90 degrees because as we rotate 90 degrees, that reference triangle gets rotated as well. Okay, so we have this reference triangle in here when we rotate to the right 90 degrees. And when we do that, what ends up happening is the x and y coordinates flip. And one of them becomes negative. So in this case, it becomes negative y. The vertical distance now becomes a horizontal distance, and the horizontal distance now becomes a vertical distance. If we do another 90 degrees, they flip again. So this coordinate is going to be negative x, negative y. So it's actually, if you think of 180 degrees, we just go in the opposite direction. So instead of going positive, we go negative. And then if we rotate another 90 degrees, we're just flipping x and y and making one of them negative. So this coordinate becomes y to the right and negative x down. So we flip the x and y, and the y position, the first coordinate changes signs. And this is actually a generalization we can make for 90-degree rotations in a circle. So lastly, when we're looking at positioning, we can determine whether ratios are positive and negatives just based on the quadrant they end up in. So for example, if we take a look at sine of 210, well, 210 ends up down here in this quadrant, quadrant 3. So because of that fact, we know that it must be negative. Sine is vertical, it's going down. Cosine is horizontal. So when we look at cosine, we have to figure out what the horizontal positioning is. Well, we need some references. So 1.57 is pi over 2, 3.14, and this is going to be about 4.72 or 3. So in this case here, 4.3 ends up in quadrant 3. Well, in quadrant 3, for cosine, we are left. So it must be a negative value. Tangent is slope. Well, 4 pi over 3, that's going to end up in quadrant 3 again. Okay, it's going to be pi is here, pi over 2 is here, and this is 3 pi over 2, which is not as big, or which is bigger than 4 pi over 3. This is negative slope, this is positive slope, so we know that it is sloping in a positive sloping direction. So we know that the tan must be positive. And then lastly, negative 430 degrees, well, we're going to go backwards a full 360, plus another 70 degrees locates this coordinate here. So we're talking about sine, so we're talking about vertical, it's down, so then this value must be negative. So we can determine the sign of these ratios based on the quadrant they end up in.